Welcome back as we continue our study in the coordinate geometry. Right now, here we are in the video. We will need at least to extend our knowledge in the line because we've said that this topic is entirely there for the study of the line. So here we're discussing the line in two different folds. We have started looking at the gradient, that's where we say every line has a slope, and we have also introduced issues about the distance between the points, because we know for sure a line is just like a connection of several points. So if you talk of the end points of that line, how do you find the distance between the points? Right, today we are there, we're going to discuss again the line itself, but in this case we have a different story all along. We need just like to introduce the issue about the straight line. Let's say talk of the equation of a straight line, to mean that the line that will be drawn on the Cartesian plane must have an equation. So which you can use the equation to draw the line. Without wasting time, can I have one problem that I'll use to discuss with you in order to obtain the equation of a straight line. Right. So here, let us consider this example. Right. You can have different lines which are connecting different points on the Cartesian plane. Like this one here, we have got a line that is connecting 2 points, and we need to work out the equation of which. Find the equation of a line segment joining or that passes through the following points. 1, x0, y is 2, and x3, y is 4. Right. So in this case, if I'm to draw this line segment, it's something that we go something like this. Here's my graph plot. We will first identify first point of this line, which is 0,2. So on the Cartesian plane here, the position 0,2 is here. So let me use a different mark. This is 0,2. So the line is passing here. And we are told that this line is also passing through another point 3,4. So x3, y is 4. It is this position here. Right, this is x3, y is 4. Right, so if the line is to be drawn, that line has to pass through those points like this. So this is the line I am drawing, and is passing through the 2 points. You can even extend that line further. Right, no problem with that, because it will always have the same gradient and the slope is the same. So let me define this one as line HQ. Right. So as I've drawn that line, has the slope, has the distance between Q and H. You can calculate the distance. You can calculate the gradient. Now let us know the equation of that same line. All right. How to work out the equation of the line? There are several ways, but here we're just going to discuss only 2. Like the other one is just like an extension of the first one that we're going to discuss. Right, one is a direct method where we're going just to use the knowledge of gradient. Secondly is the way where we are just going to use the form of the equation of the straight line. Any line has got its own form. Right, what is the general form of all the equations in the category of the straight line? They have got a general form. So it means if you want to find the equation of the line, one, you can use the general form, which is the equation of which? General form of the equation of the straight line. Number 2, you can use the knowledge of gradient. Right. So let's begin with the knowledge of the gradient. What knowledge should we incorporate in order to come up with the equation of the line? The good example is here, and the line has already been drawn on the graph board. Right. So what we need you to do in the first method, by knowledge of gradient, what you're going to do is the following. Take note first that this line is passing through 2 points. Knowledge by gradient. One is 0,2 and what? Talk over 3, sorry, that's 3,4. Now, what you're going to do here, in this case, you are going to work out first the slope, the measure of the slope of this line, which is the gradient. So what I'll do here, I'll work out on the gradient first of this line. So you know the gradient of the line is defined by a ratio of the change in y coordinates to change in x coordinates, which we're now going to write down. You talk of what? y2 minus y1, then 2x2 minus x1. So that's like the change in y coordinates, y2 minus y1, to x coordinates, that is x2 minus x1. So you calculate the gradient. So in this case, from what I indicated earlier, you're going to decide, there are 2 points here. Each point have got 2 coordinates, x and y. You're going to define which one should be ones, which one should be twos. So that one goes by your choice. If you choose that this point is the second to you, and this one is the first one, then all the coordinates here are defined by 2's. So this would mean this is your x2, this is your y2. Then this one will have coordinates which has to be defined by the notations ones, to mean that this should be x1, this one should be y1. So allow me to consider that these coordinates here are defined by 2 notations and here 1 notations. So what it would be mean here, it would be like y2 in this case is 4. That should subtract a 2 over 3 is for x2 minus what? A 0. In this case, that's what we have. So if I'm going to work out the gradient for this one, the gradient here is equal to 2 to 3. It means along the y-axis, we have changed 2 units, and along the x-axis, you have changed the 3 units. Right, so that it is the measure of the slope of the line to go what? QH. It's measured by that. Now, we have the gradient. Remember, the first method is by gradient knowledge. So it means there you have to calculate the gradient of that line. So what does this tell us? It means that along this line, no matter how you can produce to whatever position, the gradient here will always be the same. Right. So being it the same, what we have here, it means all other points here that have got also the same what? Gradient. As such, in attempt to find the equation of this line, which has got the same gradient at each and every what? Position, at every circumstances, we have got the same gradient for all those points. What we need to do here, we are going now to represent all other points within that line by a certain representation. So we're going to have a certain point that is going to represent all other points which have not been included in our discussion. Remember, so far, what we know is the line is just passing through this point and that point, which are 0, 2, and 3, 4. But you have to remember that this line has got several points. Several points. These are just like a scratch. The two are just like a scratch of the points which form this line. But the gradient we have here, this is the gradient for all the points which form this one line, between any two points within that line. So let's have a representation of other what? Points. So here we say let all other points be represented by x, comma, y. Because we know for sure every other point that we are going to identify within that line, we have the same order of values. They'll have the value of x and the value of y. Right, so here you'd say, let other points be represented by, you can choose any other point, like say let it be b, which is defined by x, comma, y. So all other points have to be included in this case. The moment we discuss the gradient, it means we have to consider the gradient is meant between 2 points within that line at any position. The gradient will always be 2 to 3. Right, as much as we talk of this line, all the points there, we have that. So the moment now we have introduced this one here, what we do now is this. We are to choose 1 point from the given one. We were given 0, 2, and 3, 4. These are the 2 points which we are told this line is passing through. And we have used them to calculate the gradient as 2, 2, 3. This time around, we would like going now to involve this point here, xy, for all other points. So we use this one to calculate the gradient for the second time, or once again. Right, so here we're going to involve this point and one of these points. So here is your choice. You can choose this point and this point, you calculate the gradient. If you don't want that, you can still consider this point and that point. So here I would encourage you just to choose one. It's not the must that say, would you always take that point or say this point? No, choose 1 point, involve it with this representative. This is just like the representation of all other points. So like in my case, I'll choose this one, point 0, 2. So here I'll write gradient again. I'd like to calculate the gradient between p, x, y, and the talk of what? 0, 2. Right. So taking me right here, 1, calculate the gradient. If gradient is not given, using the 2 points, like here, 2 to 3. Secondly, introduce another point. This is just like a general point. Since it's general, just have the coordinates defined by x and y, because it can be any one of those points. Use this point and any other point from the given 2 points to work out the gradient once again. So this is what I'm going to do here. So this point here will be regarded as 2s, this one as 1s, such that this is my y2, this is my y1, x2, x1. So if I'm to calculate the gradient, it'd be like y subtracting what? A 2. And then here, it will be like what? X subtracting what? A 0. Right. So this is the gradient over the same line. But now we have calculated gradient with different points. This one and another point there. But now the fact that the gradient of the line is the same at every position, then now from what we have here, you're going to realize that you have got 2 gradients. One is this one. The second one is more like an expression which we have here. So to us, this simply means this is an expression. This is just like a little, this is more like a fraction, has got the value there for numerator and denominator. So here what it means that the gradient, we have here 2 to 3, and the gradient y minus 2 to x minus 0. The 2 gradients must be the same. So what we're going to do here, we are going to coordinate the 2 gradients. You form an equation. The moment you work out that equation, then that is the equation of that particular line. So work out 2 gradients just by what we have done here. Right. So how do we further our discussion in this case? So here, what means it's y minus 2 to x minus 0. This should be the same as 2 to 3. Right, gradients cannot be different within the same straight line. So once we have that one, let us see, just cross multiply. It's more an equation, it's already an equation, but now let's have an equation which should not have fractions. But rather the equation is the same. This is an equation. Right, so what do? Let's cross multiply this, multiply by that one, this multiplied by that. So what we have here, we have got 3 in brackets, y minus 2. Then here we have 2x minus 0. I'm still maintaining a 0 because at one moment in time, it might be a 0, it might be another number. But we know for sure x minus 0, that's just good, just writing the x. So I'm just maintaining that for the sake of others who might say, why are you just writing one variable there? You are leaving this number. But we understand that this minus this one just give us a 0. But here, at another moment in time, it will not be a 0. Right, but now in this case, I'm going to omit that 0 because x minus 0 answer is x. Right, so here we have got 3 open brackets y minus 2. I have to remove the brackets, then what I'll have here to be 3 y talk over minus what? 6. That gives me what? Talk over 2 multiplied by x talk of what? 2x. Like that. So that's what I have. So formally, you have got preferences on how best you can present your equation. This what you have is already an equation, but sometimes it's better that say you have terms of one variable being on one side, or variables being on one side. While you have got a term without a variable, should be on the other side on its own. Right. So what I'll do here, I'll have my 3y indicated like this. Then this comes here to be minus 2x, and this gives me a 6 as such. Right. So that is your equation of this straight line. The equation is defined by 3y minus 2x is equal to a 3. Method number 1. Right. But now, let us try to tamper with this equation by writing it in a different form. What form do we need? Let us try to make it talk of the y the subject of the formula. That is an equation 1, but now I would like just to write this equation in a different form. By making y the subject, y should be found on its own side. Let's try to do that. So in attempting to make y the subject, this is what we are going to obtain. In attempting to make y the subject, if you make y the subject in this equation, this is what we have. 3y minus 2x is equal to a 6. You're going to agree with me that say this one should go to this side, and we have got a 3y on that side. Then here we have got a 2x plus a 6. To make y the subject, what do? We have to divide every term by a coefficient of y, which in this case is a 3. So when I divide this one by a 3, I have y. This one divided by 3, I've got a 2 over 3x. This one divided by 3, I'll get what? I'll obtain a 2 as such. So now, let us look at 2 categories of equations, which are not different, they're just the same, only that way we have presented them is different. Here, it's just an equation that we have it, but in this case, we have written in the form that y should be the subject. Fine. There's something that is very interesting. And out of it, in this form, we are going to obtain a general form of the equation of all straight lines. That one, you may also use it to wake up the what? To go the what? Equation of the straight line. We have the equation of this by what we have done. This second one has been obtained by making y the what? The subject. Right. Now, what is it that I want you guys to know? I'll go back to the original board. Look at this line we draw. If we're going to at least compare what we have on this line here and the equation that we have just obtained by making y the subject, you're going to realize that first I have to connect this one. Okay, let me just have this one up as it is. You're going to observe that, say, if you can look at this equation critically, compare with the line that you have drawn here, you'd find that this line is passing or is intersecting the y-axis at one position. You find that this line is intersecting the y-axis at a position what? A position 2. If you look at this 2, to you, this 2 is the y-intercept of this line. And now if I go to my equation which I've obtained a representation of this line, I would find that this 2 here has got at least a place within that equation. I'd find that this 2 is here. And this 2 has got no variable attached with it. You can see here. Here is the 2. Here is what? Is a 2. So it means when you make the y the subject of the formula in a particular equation, you make y the subject of the formula in the equation of the straight line, you're going to have a value which is defined as the y-intercept. When you make y the subject, look at this equation I have here. Here, y is not a subject. A value which has got no variable here is a 6. You cannot say the y-intercept for this line is 6, no. But only when I make y the subject, I have a 2. So when y is the subject, in this case, we are able to observe a y-intercept in an equation. So it means an equation of this line should be able to show a y-intercept like this one here. Secondly, if we can be able to study this one again, this equation here, it found that somewhere we're able to calculate the gradient of the line. And in this case, we found that the gradient of the line that we calculated earlier in the first instance, it was 2/3. Now, let us look at the two categories of the equation that we have obtained here. The first form of the equation is this one. It's just correct. You're going to realize that in this case, your equation is this one here, but you can't even see the 2/3. But when I make this equation, when I decide to write that equation by making y the subject, I'll find that what I have is this. So what is here? You find that the gradient is also what? Being spotted out. So just like when you make y the subject, the equation will be able to show you the gradient and the position of which, and then it also show you the y-intercept. So here the equation of the straight line must be able to show the gradient and the y-intercept. And this is only possible when y is the subject. Here the gradient, which is found in this one, y tells us it's just like the gradient is always the coefficient of x variable in that equation. And the constant value without a variable, most of the times, that one is your what? Y-intercept. So this one has got y-intercept, has got the gradient. You can have them only when you make y as the subject, as we have done here. If you don't make y the subject, please, you can't locate the y-intercept and the what? And the gradient. Right. So, as such, if this is the case, we have the gradient, we have got the y-intercept, then we can introduce what? The general form in this case. Right. How would be the general form? Since we know that gradient will not always be the same, we have got different lines with different slopes. The means of the slopes will have got different gradients. In this case, we can say, let the gradient of a line be represented by letter M. And since the lines might intersect or intercept the y-axis at different position, can intercept at -5, 2, 8, things like that. So we may say, let the a y-intercept be represented by a letter, maybe C, it means the general form of the equation of a straight line will be something like this. So you finally have to like say equation of straight line will be defined by what we have here. This is my gradient. It means I've substituted this gradient 2 to 3 by m. So it means I'll have y is equal to, instead of writing 2 to 3, I'll write what? M, x. Then plus what? This is a 2. The 2 is represented by c. It means my equation will be equal to y is equal to mx plus c. When I see m, to me m is a gradient, and c is the what? Y-intercept. So this is the general form of the equation of the straight line. Right, so I have hope that you learners, you know how to calculate the equation of the straight line by what we have just introduced. Right, in the next video, where we'll be discussing other issues within the same coordinate geometry, I'll have one more example where I have to introduce issues about the general form of the straight line. So what is needed by this, I think, is just also self-explanatory. If you want to find the equation of straight line, what you do, just calculate the gradient, substitute for m, and also calculate the what? The y-intercept, substitute for c. You go like that. Right, as of now, let us stop here. We'll meet again in the next video. Thank you very much.